All right, so we're moving on to Unit 3. It's actually the AP's Unit 2. So the AP learning objectives that these videos are going to cover are 2.1 and 2.2. We're also making the jump from kind of Unit 2 to Unit 3. We're switching our focus from limits, which is what we focus on for pretty much the first 2 units. And now we're going to talk about the second big thing that happens in calculus, which is derivatives. So we'll figure out what a derivative is and start using those for probably the next 4 units. All right, so in this video, we're actually going to do a kind of pre-calc thing about average rate of change. And in the next videos, we'll get into the calculus stuff. All right, so average rate of change, which is kind of a long name, so I'll abbreviate it as AROC. All right, the average rate of change of a function is the constant change that would have to occur to get between the 2 inputs you care about. All right, so here we have some function f, and we start at x equals a, and we end at x equals b. All right, then our average rate of change is going to be equal to this formula. So this is the function value at b, which is basically our y value related to b, our function value at a, which is basically that y value related to a, over b minus a, which again are those x values that we care about. All right, so that's our formula. And for applications and problems, we just have to remember this formula. All right, so we want to find the average rate of change of this function, y equals 3x minus 1, from 1 to 3. What we're going to do is think about our formula. The average rate of change is f of 3, which is b, minus f of 1, which is a, over 3 minus 1. And to kind of simplify the process, you could do it all in this one equation up here, but I'm going to kind of go to the bottom. We need to figure out what f of 3 is, right? This is function notation, meaning I'm plugging 3 into my function, so I can do that down here, f of 3. Well, if I plug 3 into my function, it'll look like this, and I'll get 8. So f of 3 is equal to 8. Also need to figure out what happens when I plug in 1 into my function. F of 1 is, now I'm plugging 1 in, and I get 2. All right, so now I can rewrite my formula. F of 3, that's the same as 8. So when I plug in 3, I get out 8. When I plug in 1, I get out 2 over those x values I started with. 8 minus 2 is 6, 3 minus 1 is 2, and I get 3. So on average, I'd have to change by 3 units every single time as I go from 1 to 3. All right, what about if we're looking at a graph? All right, there's a lot of these types of problems on the AP exam. Again, I'm looking at average rate of change from 3 to 7. So first of all, let's look at the formula. All right, 7 is b, a is 3. And we have to get our function values in a different way. So at f of 7, my x value is 7. When I put that into my function, I get that point whose y value is 3. So f of 7 equals 3. For f of 3, now I look at my x value 3, and I get that value, and that value's y value is 1. So f of 3 is equal to 1. All right, so it's the same thing we did in the last one, we just get our function values in a different way. So now we get f of 7 was 3, f of 3 was 1. That gives me 2 over 4, which is 1/2. Right. So 1/2 is the average rate of change of this function, which means every single time I go to the next input, my output has to change by 1/2. But actually, there's something, you might have seen formulas look like this before, where you're kind of subtracting one thing on the top and stopping one thing on the bottom, and it would look like this. And if you recall, this was the formula for the slope of a line when you're subtracting 2 y values, and that's exactly what these were. These were y values. Over, you're subtracting 2 x values is the slope of a line. And that's actually exactly what's happening in this problem. If I look at the 2 points I cared about, my answer was 1/2, but slope is also rise over run. So these are all kind of things you've probably learned before. Maybe you're just remembering them now, but slope is rise over run, which means if I rise 1, then I run 2, that gives me the next point. I rise 1, run 2, and you can see that gets me there because this line that connects these 2 dots, the slope of that line is the same as the average rate of change. All right, so average rate of change has its own formula, but it's actually related to a formula that you've learned before. Right. So this is kind of it written out in words. Right. The average rate of change as a function is the same as the slope of the secant line. Secant line just means if I have some function, it connects to points on my function. So this green line would be a secant line because it's connecting two of these points. All right, so the secant line slope is the same as the average rate of change. So whatever the slope of this green line is, it would be the same as the average rate of change between these two blue dots. All right, so that's just one thing to remember. Average rate of change is related to slope.